Hello to JCB viewers. Welcome to JCB EduBuild Solutions, founded by engineer James Bolo. Today, our discussion will be plumbing arithmetic. This section makes up 10% of your total exam weight, but the real challenge is the volume. You must complete 100 items in exactly 2 hours, leaving barely over a minute for each calculation. Test takers frequently run out of time because they rely on long-form manual algebra. Writing out every step of a solution consumes minutes that the exam schedule does not provide. We are going to bypass traditional manual solving. By the end of this review, you will be able to use specific calculator techniques and specialized formulas to reach the correct answer directly. These shortcuts prevent a blind rush through the paper, ensuring enough time remains to process the most complex items at a deliberate pace. Look at this page detailing linear equations. We map real numbers onto a coordinate plane, finding x and y intercepts where the line crosses the axes. The slope, or m, is then calculated using the rise over run formula shown here. Exam problems often ask for the exact point of intersection between two linear equations. Solving this by manual substitution is a slow, multi-step process. On a standard scientific calculator, entering mode 5.1 opens the equation solver. You simply input the coefficients, labeled here as columns A, B, and C, into the matrix for both equations. For the equations x plus y equals 3 and 3x minus 2y equals 4, you plug in the isolated numbers. Pressing equals provides the immediate solution, x equals 2 and y equals 1. Translating algebraic equations directly into matrix inputs removes the manual arithmetic steps where small mistakes typically occur. This saves minutes on every problem of this type. Age problems are most efficiently handled using a fixed structure. Immediately draw a timeline table like this, plotting your variables strictly in the past, present, and future columns. From that table, the algebraic equation is extracted directly from the text. For example, stating Aldrin's age in 15 years will be twice Alvin's age translates to the equation y plus 15 equals 2 times the quantity x plus 15. Mixture problems follow a universal two-equation rule. Equation 1 represents the total weight, x plus y equals 2,000 kilograms. Equation 2 accounts for the percentage composition of the individual materials. Once these two standard equations are written, apply the same mode 5.1 calculator technique. This provides the component weights, x equals 500 and y equals 1500, without manual derivation. Applying rigid frameworks like the age table and the mixture rule turns confusing narratives into predictable, solvable datasets. Clock problems are intentional time wasters. They rely on the test taker attempting to visualize moving hands and calculate overlapping angles mentally. You can bypass that visualization with this single formula. Time in minutes equals 2 over 11 multiplied by the new angle plus or minus the reference angle. The reference angle is the initial position, and the new angle is the target. Use the plus sign when the minute hand has crossed the hour hand. In this example, 0 plus 90 degrees yields 16.36 minutes. For work rate problems, such as 2 pipes filling a tank, total work is the sum of individual fractional rates. If pipe A takes 4 hours and pipe B takes 6, the equation is 1 over 4 plus 1 over 6 equals 1 over the total time. Rote memorization of these specific time and rate formulas is required to maintain the speed necessary to complete the exam. In the physical world, direct variation means variables increase together, while inverse variation means one increases as the other decreases. These concepts apply to practical plumbing, such as calculating the pump horsepower needed to lift a specific volume of water against gravity. First, determine the discharge, or Q. By converting 50,000 pounds into cubic feet and dividing by the 5-minute duration, we find a discharge rate of 2.67 cubic feet per second. Apply the power formula by multiplying that discharge by the unit weight of water and the total height. Dividing the result by 550 foot-pounds per second provides the final answer of 60.6 horsepower. These arithmetic operations are the foundational principles used to safely size and power real plumbing infrastructure. The mode 5.1 matrix, the 2 over 11 clock formula, fractional work rates, and the 550 horsepower conversion factor provide a direct path through the high-yield arithmetic items. Test these precise frameworks on past board exam questions now to build your speed and muscle memory before the test. Thank you, JCB viewers, for listening. And for those who are not yet following, please follow us for more contents and free reviewers for you. See you on the next topic.